Hi, my name's Andrew Sagl. I'm a product manager with Megger, and what I'd like to do is talk to you a little bit about some motor testing today. Now, motors are the most common piece of equipment in industrial applications today, and we'll see them start and stop multiple times each day. Each time they turn on, they draw a very high level of inrush current, and motors will draw several times their full load current when they're turning on. Even small motors can draw up to 6 to 10 times their normal current on an inrush. These large currents can actually lead to voltage dips. And when you get these voltage dips, these can cause issues in the plant, such as lights dimming, loads tripping out, disruption of sensitive equipment, and protection devices. A large enough voltage dip can actually keep the motor itself from starting. Characterizing inrush currents and their effects requires a monitor that can capture the waveforms for long durations. Most monitors today cannot do this. The MPQ can capture inrush waveforms for over 10 seconds, and that's on every channel simultaneously. In addition, the MPQ can monitor the motor for days or weeks at a time, and it will capture that inrush current every time that motor starts. And the installation of variable frequency drives, or VFDs, is rapidly increasing in industrial plants. Plant systems may not function properly with VFDs. Aside from potential harmonic issues, VFDs can react with the plant's electrical system and cause transient voltages. High-frequency transient overvoltages and voltage notching can cause equipment to malfunction. VFDs can also excite resonance and cause damaging overvoltages. The MPQ has a recording scope ability, so you can leave the unit connected, and not only will it record inrush current, but it will periodically capture timed waveforms up to 200 cycles each. So you can leave the unit in place for months on end, and it can help locate those intermittent problems. When analyzing motor issues, you need an analyzer that can record multiple long-duration inrush waveforms. The recorder must also be able to record for extended periods of time, and it has to have the power to analyze that data. The Megger Power Quality Analyzer offers all of this in one small package. The MPQ is one of the simplest analyzers to connect. We're first going to connect the voltage leads. And the current clamps on this unit. The unit comes with 4 range current clamps. So this is like having 4 current clamps in one. So I'm going to connect the current clamp to the analyzer, and then I'm going to set the range. And in this particular one, I'm going to set it to a 60 amp range. Now the current clamps are powered by the analyzer, so no batteries or extra connections are required. And the analyzer will also automatically recognize the current clamps and the range to which they are set. So there's no need to program the CT type or the CT range. Now that we're connected, we just select the configuration from the front panel. So I can come over and I can select all different configurations. And I'm just going to come over here and select my 4-wire Y. So now I can see my voltages and my currents right here. I can come over and I can see my power and my phases. I can also use this as a vector scope, and I can see the vectors and I can see my imbalance right here. And of course, I can use this as a scope and literally see all my waveforms right here. And I can capture them, and I can zoom into them, and I can create scan lines and actually pan through them as well. But now that we're set up, we can basically now start recording. The unit is smart enough to know if it's connected properly, and it will let you know if there's any problems and how to correct it. Now that the unit is recording, it's going to be recording cycle-by-cycle data. It's also going to be capturing waveforms up to 10 seconds on every time the motor starts up. And when it does the cycle-by-cycle data, this is going to include voltage, current, active power, reactive power, apparent power, the phase angles, the cosine of the angle, and the power factor as well. This is all recorded every cycle. And as I said, plus every time the motor turns on, we get a waveform capture on all active channels for over 10 seconds. So now we can let this record for hours, days, or weeks. And now that the recording is done, we can examine the data. Now let's look at the RMS. Now we can clearly see all the motor turn-on cycles, and now we can also zoom into this. And now, when we zoom in, we can clearly see the voltage dip that's associated with this inrush. And we can pull up a scan line, and we can actually see the values associated with them. So now let's go look at the actual inrush waveform that was triggered by this turn-on. The analyzer will first show you how many events were captured, the total number. And we can see that this had 13 events that were captured. So now we're going to select those. And the next thing the analyzer will do is break down the events by the days that they occurred on. So if this recording was multiple days, we would see how many of these events occurred on each of these days, so we could choose the day we want to look at. In this particular recording, it was just one day, so we're just going to choose that day. And now I'm just going to scroll down to the event time, and we take a look at that. And we can see the inrush current here. We can also zoom into this as well and get a closer look at it, and we can create a scan line, and we can actually view the peak value. So now let's transfer the data to the PC and take a closer look at it. So the data has now been transferred to the PC, and from here I can view the cycle-by-cycle voltage, current, kW, kVAR, kVA, as well as the power factor throughout the entire testing interval. But let's look at the cycle-by-cycle current inrush. We can clearly see the inrush from each motor turn-on. Each diamond is a link to the waveform that was captured for each inrush. Click on the diamond, and we can view the waveform for each inrush. And you can clearly see these waveforms are 10 seconds long. We can zoom into each waveform and analyze it. We can create a harmonic analysis by clicking on a button. Now we select the cycle and view the harmonic data for this inrush. I can then create a harmonic analysis report with a simple push of a button. Using the timed waveform recording scope ability, I can trend all the captured waveforms. I can trend them based on different harmonic orders. I can scan through them and examine each waveform. And with the click of a button, I can perform a detailed harmonic analysis. I choose the cycle, and I can see the harmonic content. I can view the harmonic content through the 128th order. And I can see that this VFD had harmonics up to the 67th order. We can then create a report with just the click of a button.